Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSS sheet, and this is the time to start with tree data structure. Yes, but before starting with all the patterns and the questions inside it, we have to learn the basic traversals in tree, which are DFS Traversal and BFS Traversal. So in this video we'll see what is DFS Traversal and what are the different types of DFS traversals. I hope you all know that what is tree data structure. Tree are basically those data structure which are called non-linear, and it can have 0 number of children, 1 number of children, or at max 2 number of children. So hence we have to traverse also in that, because indexing is not there in tree data structures, right? So from root to child means the last node, which is leaf node, how can we traverse? So basically there are two ways. First is depth first search, where we have to start from the node and we go for children's. Means we have multiple options for children, but we decide to choose to go for only one child. So hence we decided for 2. Again for 2 also, now it means now instead of going at 3, for 2 we have multiple options which are 4 and 5. So hence we decide to choose any one child, which is 4. You can either choose 5 also, but let's suppose we are choosing 4. So I can say first we chose 1, then we chose 2, then we chose 4. If we would have chosen 5, then after 2 it would have 5, then it would have 4. So although in DFS also we have multiple traversals, and that also we'll see. So this was depth first traversal, where we start from the root node to the leaf node. Second one is breadth first search. In the breadth first search, first we cover the root and then we cover all of its child nodes at that level. So then we print 2 and 3. Now in the next time, suppose 4 also have child 8 and 5 also has child 9. So in the next time 4, 5, 6, 7 all are at same level. So we have to traverse all of their children's at the same time, and next time 8 and 9. So this is called breadth first traversal, for which queue data structures are used. But as we are focusing on DFS traversal, so in this traversal we will use stack data structure. So there are two ways for DFS traversal also. First is iterative way, where we can insert the node in the stack, and on the basis of how or what node we are inserting first, we will pop and then insert their next children. Again we will pop and insert their next children. Again it depends on the algorithms as well. But the other way is recursive approach. Yes. So if you don't know what is recursion and have not watched the full playlist of recursion which we have already recorded, I'll attach the link somewhere here, then don't jump onto this topic, because tree are mostly solved using DFS or BFS traversal, where DFS needs recursion, because not every time you will be solving with iterative approach. Now remember, I said ki in DFS traversal also we have 3 ways, and those ways are pre-order traversal, second is in-order traversal, and third is post-order traversal. And what are these? See, when we started from the root node, I hope you all know this is root node, which is parent node, and these are children's, for which we call this left child and we call this right child. Remember? So for every node, it will have left or right or both or none. Okay. So now when we started, or we are standing at root node, okay, on what pattern or on what sequence we want to print this root node, left node or right node, that says what traversal it is. Suppose you want to do the pre-order traversal. So first we have root node, then we have left node, and then we have right node. Pre says pre, in and post. These definitions are only for the root nodes. So left and right will be sitting at the same position. Left, right, left means left first and right later. If the root comes at first, it becomes pre-order traversal. Now if the root comes in between the left and right, it becomes in order traversal. In means in between. Or if the root comes after right, means first left, then right, then root, it becomes post order. Post means after. So in pre and post depends or says the address or location of root when you want to print that. Very simple. Now let's see how can we do in-order traversal in this tree. So remember the definition of in-order traversal. What is the meaning of in? In says left will come first, then root, and then right. Remember? Okay. So we are at root 1. So what do you think? We should print this one or we should go for the left call? Definitely, because the pattern says ki we should go to the left child first and then print the root. Remember? But the thing is ki can we go to the root child left or right if root does not exist? Means what if here is, so we can see our tree. Okay, from here we'll go to the left child, from here we'll go to the left child, from here also we'll go to the left child. But what if the left child does not exist? Then do you think going towards its left and right child makes sense? Means what if node does not exist? Then can I say ki hey, null has its left child or the null has its right child? No, we cannot. So hence in all the recursion, it is very important to write the base case, because the base case plays two roles. Two roles means suppose at starting only we don't have any tree, it's null. So in starting only the base case can say ki if root is null, return. Return means don't go anywhere, return then and there. Okay. But the same base case which we are thinking ki it will work for the first node, but it will work for the last node also. Why? Because here you will check ki root exists. It says yes, root exists. It's not null. Okay, then go for the left call. Now how we can go for the left call? Can I say when we have, like here we have choices, either we can go towards left side or either we can go towards right side, correct? So wherever we want to go first, we will call the function recursively for that direction. So let's say we have a function here and we are sending root here. Okay, so now what we are doing, if we are at root and we know it's not null, then I can say I can go to left or right, correct? So if we are going towards left, so what I am saying, call the same function. Okay, let's call it DFS because it's depth first traversal, right? Depth first search. So DFS. Now root dot left. So I am saying I am at 1, but I want to go to my left child, which is 2, correct? So now the moment you will call this now after this line of code, whatever you write, that will not run until or unless the root will become null for sure. How? This is root. You will say it is null. No, it's not null. You will go for the left call, which is 2. Now again you will check, is my 2 null? No, it's not null. Again you will go for 2 left. Okay, 4. Now again you will say 4 is null. No, it's not null. Again go for 4 dot left. 4 dot left. Now you will say, is it null? Yes, it is null. So now you will return. So now 4 dot left will return and now it will go for 4 dot right. Can I say that? But to go for 4 dot right, there should be next line of code. Can I say? So let's say DFS root dot right. But what was the traversal we were doing? In order. Can I say? Means first left will come, then root will come, then right will come. Correct? So first, this is root. This we are not supposed to insert. First we want to print left. Okay, we went on to left. Again for this also, this is a root na. Means for this subtree, 2 is not left, 2 is root again. Okay, then we'll go for the next 4. Now again for 4, this is not left, this is still root. Now it will call for left child. Now it will call for left child. Left child will say, hey, I am null, so it will get returned. So after this line of code, it will get returned. Now we are here. Now we can say ki, hey, this call, like when we were going down, 4 was acting as a parent. But now as we have returned, so now 4 is no more parent. 4 is 2's left. That's what we want to print, correct? So in between the two calls, we will write, let's say we make a array. So array dot add root or dot value, whatever we want to print. It's very simple. So in the array, suppose we had an array. So in the array, 4 will get printed. Now what will happen? Next time what will happen? Okay, so 4, like 2 what sets left, it got returned. Now after that in array root dot value got added. Now next time we want to go for right child, because that's what it said na, left root then right. So we want to go for the right child. So that's why DFS root dot right. Now further DFS root dot right will say ki, hey, my root is null. So now this will also get returned. Can I say? Now after this we have not written anything, so by default it will also get returned. Means here. So for 2, if you remember, let's visualize through the recursive stack. Okay, recursive stack. Here we had, right? So I'm just writing function for 1 we called. After that we called for function 2. Now after 2 we called for function 4, because left only we are calling. After 4 we called for function 4 dot left, which was null. When this got returned, we went to function 4 again. Now again from function 4 only, function like 4 dot right get called, which was again null. Again when this was also got returned, we returned back to 4, correct? Now when 4 got returned, remember 4 got returned and it went back to 2. Okay, so 4 also got returned, done, and now we went back to 2. Now 2 said, now print me, correct? Why print me? Because from 2 left we already got returned. Now it's time to print root, because that's what Inorder traversal says. So hence again array dot add root dot value. So here we will add 2, correct? Now right side. Now 2 right side. Again DFS root dot right. Means, can I say function for 5 will get called? So from here function for 5 will get called. Done. Now again for 5 also left will get called, correct? Function left. Again it will get returned back to 5. Remember? And now when 5 function, like 5's next call will get returned, can I say left has been returned? Now it's time for root, which is 5. So again in the array we will add 5. Done. So now this time we will call for function 5 dot right, which is again null. Okay. So now null will also get returned. So can I say this will get removed? Done. Let's remove this. Done. Now this done, this done, this done. So after this line also by default it will get returned, means 5 will again return to 2. So let's remove 5. Let's remove 5 returned. This also, correct? Now 2's left returned, 2's right returned, 2 also has been printed. So now this will also get returned to 1. So this was 1's left. This was 1's left. Now we will call for 2 got returned, right? So we can remove 2. Now we will call for 1 dot right. 1 dot right is nothing but for function 3, correct? Now for function 3 we will call for left, means function 6. Now for function 6 we will call for 6 dot left, which is nothing but null. So 6 dot left will get returned, correct? And now after that when 6 dot left got returned, again 6 will act as a root, so 6 will get added here. Now further we will return 6 back to 3, correct? So we will remove 6 call, correct? Now back to 3. Now for 3 we will call for 3 dot right. 3 dot right is nothing but for function 7. Done. Now for function 7 again we will call for left, which is nothing but null. Now when null will get returned back, because of this root is null return. So now 7 dot root, like root dot value, means 7 will get added here in the array. Okay. And now 7 dot right call, which is again null, will get called. Now again root is null, 7 dot right, so it will get also returned back. So here we will return 2, 3. Now can I say null will get returned? Okay, returned. 7 will also get returned. And can I say before 7, 3 will get inserted. Why? Because once 6 got fixed and we went for right call, so before right call array will add the root dot value, correct? And remember when this called returned and we called for 1 dot right, remember? So before 1 dot right, 1 will also get inserted in the same array. So can I say before 6, 1 was get inserted, correct? So at the end 3 will also get removed. So now this also has been returned, this also has been returned. So 1 dot left has been returned, 1 has been added, 1 dot right also has been returned. So at the end we will return from this main function, which is DFS. Now you tell me, for the preorder traversal, pre means root first, then left, then right. So can I say just this line of code if we will add here means when we are at root, I'll say just add it. Add it means 1. Then go for left, right, 2 or 3. But first so you will go at 2. Again you are at 2. So root. So let's print 2 first. Now again go at left, right. But first so you will go at left. So you will go at left, 4. Now again 4 is root. Print root first because that's what preorder says. Now go for 4 dot left. It is null. You will get returned. Right. You will get returned. So now this will get returned back. Why? Because you have added 4, you went for left call for 4, right call for 4, returned back. So now this line you will return. So 4 will also get returned. So for 2, you added 2 and you returned also from left side. So now for 2, you will go for right side, which is 5. So now 5 is a root, so 5 will get added. Again for 5 left, right, we have nothing. So 5 will also get returned. So for 2 got added, left got returned, right got returned. So now 2 will also get returned to 1. So for 1 got added. Yes. 1's left also added. Yes. Now it's time for 1's right. Now for 1's right, which is 3 is the root. So 3 needs to be added. Now 3 is left, 3 is right. But first we go for left. So 6. Now 6 is a root. So 6 will get added. Now for 6 left and right, they are nothing. So we will get returned from here and 6 will also get returned to 3's left. Now we'll go for 3's right, which is 7. And 7 is a root, so 7 will get added. Now for 7, left, right is nothing. So we'll get returned to 3. Now for 3, left got returned, right got returned. So 3 will also get returned to its function. Now for 1 got added. 1's dot left got added, 1's dot right got added. So at the end, it will also get returned to the main function. So at the end, this array is nothing but preorder. Now similarly, can I say this line of code will get added here. Here means we are at root, right? First left, first left, first left. Now left will say, hey, I have been returned. Now right will say, hey, I also have been returned. I am null. So add root now. First left priority, then right priority, and then the root priority. Okay. So 4 will get added. Now 4 was 2's left. So we'll not try add 2 now. We'll go for right child because that's what we say. Left child, then right child, then root priority. So we'll go for 5. Now for 5 also left null, right null, and now we'll add 5. So after 4, can I say 5? Now this will also get returned after 4. So now for 2, left has been returned, right has been returned. So now it's time for root's priority. So we will write 2 here. Now all this was 1's left. Now we'll go for 1's right. Then only we'll add root, correct? So for 1's right, 3 is root. So we'll go for left. 6 is root. So we'll go for 6 left. Return. Now 6 right. Return because it is null. Now we'll give priority to 6. So 6 will get added here. Now 6 is nothing but 3's left, got returned, but we have to check 3's right also. So for 3's right, 7 is root. We'll go for 7 left, return, 7 right, return. Now it's time for 7 priority, so we'll add 7 here, done. Now for 3's left also has been returned, right also has been returned. So now it's time for 3's value to get added. So we'll add 3, but now 3 will also get returned. So for 1, left has been added and returned, right has been added and returned. So now it's time for root value, which is 1. So that's what Postorder Traversal says. So if you understood this with the stack calls, means preorder, inorder and postorder traversal. So can we solve, means write the code in the editor of the lead code and we can mark 3 questions from our sheet from the DFS pattern. So let's write it. So here is a question which we have already discussed. Now let's write the code. So for code, first we will make list of integers. Remember, integer. To save here, let's say answer or array, whatever you want to, array list. Done. Now here we'll save all the root values. Okay. Now we will call the function for inorder. Let's name it inorder only. We'll send the root and now we will return answer array. Now our task is to make that private function for inorder traversal. Now for inorder we will send root, correct? Now the very first is base case, ki what if our root is null? So if our root is null, then return then and there. or else as it is in order. So first we'll go for left call. So let's call in order with root dot left. After this, now in the answer add what? Root dot value, correct? And after this again call for in order, call for root dot right. Done? Yes, yes, correct. And sorry, here will be a tree node type. We have not initialized the type, okay? So root will be of tree node. Now this function will help us to save or store our values in the answer array, and at the end after calling in order we will return the same answer array. Okay. So now let's run the code. Yes, done, and let's try to submit this. Submitted. Now let's see the time complexity and the constraint. The number of nodes, constraint says the number of nodes can be 0 also. For this only base case added, right? If root null, return then and there. Then answer will be empty, correct? Okay, and the maximum number of nodes can be 100. Okay, the number of nodes can be 100. Okay, so it is only 100, guys. It means we first started here, right? 1. So for function 1, like for 1 function has been stored. Now for 2, 3 also function has been stored. For 3 also function has been stored. For 2's left, right, which are nothing but 4, 5, and here 6, 7. So number of nodes is nothing but these 1, 2, 3, 4, 5, 6, 7. So in this case these are only 7. So in the stack for this, can I say 7 calls has been saved? Means for 2 left we never went again back for 2 left. Like for every node we call all functions but only one time. So can I say in the stack we saved how many calls? The number of nodes. So the space complexity will be O of n used by the internal stack because of the recursive calls. Yes, and time complexity also, we are traversing going on every nodes, right? One by one, correct? Yes. So the time complexity will also be O of n, which is O of 100, which is very small, and that is why it was very fast. So time complexity is also O of n, and space complexity also is O of n. So this was the code in Java. Here is the code in C++ for Inorder Traversal, and here is the code in Python for Inorder Traversal. So I hope you understood. If you understood, then in the we can go in the sheet and we can mark the very first question of DFS Traversal as done. Now we have also solved pre-order, so let's do pre-order traversal also. Here I have already written the code for you. Everything will be same, but as it is pre-order, so before calling the left and right, just add the value in the answer array first and you are done. Here also the constraints are 0 to 100, so definitely O of n time complexity and O of n space complexity because of the recursive stack, correct? So this is the code in Java and this is the code in C++ and here is the code in Python. So I hope you understood. Now we can go in the sheet and mark the pre-order also as done. Now the third one is post-order. I hope you all have understood how the post-order works. So for post-order, we'll just go here and we'll copy this much line of code and we will paste here. As this is post-order, so let's name post-order traversal. This is post-order, so here also we have to call post-order. As it is post-order, so at the end we have to add, right? Means after left and right call, so we'll call here, correct? Now we have to make the same list of integers. Yes, let's name it answer is equal to new array list. Done. Yes. Now inside this post order we have to call this function, okay, and we have to send the root here and at the end we have to return answer. That's it. So let's run the code here. This is in Java. Done. So the similar approach I hope you can do in C++ and Python also. The only thing is you have to change the location of insertion of the root value in the array, okay, and that's it. So with this we can go and mark the third question also as done from this DFS Traversal. So I hope you understood how the DFS Traversal works, because going forward we will do multiple questions with the same method where we will be calling the functions recursively. So understanding the stack calls with the recursion is very important, and I will make sure that I will do the stack calls representation in every tree question where DFS can be applied. So that's it for this video, guys. I hope you understood the DFS traversal. Now in the next video, we'll see what is breadth first search by solving one more question on it. And guys, we are going to solve the 3 questions pattern wise towards the whole playlist. So stay tuned, and if you have any doubt, do let me know in the comment section. I'll attach the sheet link and my social media links in the description below. That's it for this video. Let's meet in another video with some more interesting questions, topics and patterns. So keep learning, take care of yourself and your family too.